80 or 90% of all this hay went through the dryers. There might have been a little bit of first cut. I think all the second cut and third cut went through the dryers. As you can see, I think that's pretty nice green hay. You know, and talking about the dryers, it's just a tool to get your hay off quicker and in better shape. I think as, you know, dairy producers especially, they know that the shorter the window between cutting and harvesting, the better the quality, the better the feed quality. And color is representative of that too. And with our dryers, we are harvesting hay at the same time as the dairy farmers are chopping. Can. Not quite as quick sometimes. And what you see there, on the left, we're getting a premium for that. So my aim is to make premium quality hay and get a premium price for it. And it's the only way to do that. Not quite. The dryers makes that a lot easier. And you can get a lot higher percentage of your hay in top quality and get a premium price for it. As far as the dryers go, you know, they do just dry hay. Product in is product out. If you're going to take 3 or 4 days to bale hay, until you bale the hay and put it through the dryers, you're not accomplishing much. What you want to do is still do everything you were doing before to try to get your hay as quick as possible. But instead of waiting that extra day or 2 days till it's dry enough to bale, you can now put it through the dryers. And our dryers will dry any moisture, but the higher the moisture, the longer it takes, and it gets cost prohibitive from the cost, like energy cost. I know you'll have lots of questions. Some questions that we get asked is, how long does it take to dry? What kind of moisture can we dry? Well, we can dry, we've dried stuff up to 50%, but that not very successfully. And it costs way too much. But it works really well up to about 35%. It will dry anything under that, like in the drying time. It depends on the moisture, anywhere from about as little as 4.5 hours, but it's usually about 6 hours to a batch, and up to 10 to 12 hours, 16 and 20 hours too, depending. Under 20% moisture, it's going to be in that 6-hour range. If it's 25 to 30%, it's going to be 8 to 12 hours, depending on the biggest factor that makes the biggest difference is outside temperature more than humidity, which kind of surprised me. I figured the drier the air, that'll be an advantage to us, but it really isn't. It almost makes no difference. But the outside temperature does. It just takes longer to get the air warmed up. So you can add, like in the fall when it's chilly, it's down to +5 overnight and only +18 during the day. It's going to take, in the summertime when it's hot, if it takes 6 hours to dry the hay, when it's at cooler temperatures in the fall, or the odd time in the summertime you get cool temperatures, it'll take about 30% longer to dry.
What's the power source for the dryer?
Okay, the power source for the dryer is it's propane engine. And I'll talk a little bit about the dryers now. It's a 140 horsepower engine driving a 4-foot centrifugal fan. I think it's 40,000 CFM, if I'm right. Correct me if I'm wrong, any of my guys, and we're capturing all the heat off the engine. There's no supplemental heat. We have tried it already, and we will dry quicker, but it doesn't change the cost of drying. So, the time difference wasn't significant enough that we thought it's worth the extra cost. So the dryers it has baffles in it that we can actually we monitor the amount of air we recirculate. So we're monitoring humidity, we're monitoring temperature. You don't want the heat to go above 140 degrees or you're going to bake the hay, and animals will not eat it as well anyway. So if it smells baked, you've had the temperature too high. So we try to run the temperature about under the 140, more around the 120 to 130 degrees.
Fahrenheit? Or?
Fahrenheit, sorry, yeah. We switched to metric while I was in school, so I'm both.
Same.
Metric, would that be about 60 degrees Celsius?
Yeah, 140 is about 60 degrees Celsius, so we're running a little bit under that. Yeah. And we can monitor the amount of air we recirculate and while we're monitoring the humidity. There in the engine room there is a exhaust heat exchanger that helps. So we capture all the heat we can off of the engine, air coming through the radiator, and air passing through the heat exchanger. The exhaust pipe on the outside you can pretty much leave your hand on, so we're doing a pretty good job of capturing that heat. We can put 18 bundles or 18 big squares. We can do 3x3, 3x4 big squares, and the bundles. The first prototype dryers we made, we could only do bundles, and the second set that we're going to show you here, we made it so we can do big squares too. And it works equally well with big squares.
What, if any, are the biggest challenges with the dryer, whether it was a learning curve or things that you've learned along the way?
Yeah, what is the biggest challenge with the dryers? The biggest challenge is the variable moisture in the hay. You have to get it as consistent as possible. And it is going to vary. Let me tell you, it's going to vary. You think it's all the same, but it isn't. And my goal is to not have it vary more than 10%. So if it's an average of 25%, you know, you don't want higher than 30%. Okay, everybody's here. I'm going to have Joseph run a couple of the functions just to show you how it works. It has walking floor in it for loading it and unloading it. And there's a little limit switch on the loading platform that as it comes out, when it hits the switch, then it will stop and wait till you move the bales and then it will start up again. And for loading, it works the opposite way. And you can see the flaps on the top corners and also the flap on the sides. And those are all hooked together on a linkage that as it comes down, it also squeezes in the middle. So when it's squeezing the hay or coming down, and the side flaps are actually on accumulators that as it dries and shrinks, it will maintain the pressure to a degree anyway. But we're still working on the programming to get everything the way we want it. We could actually program it that would maintain it. And because it's very important to keep a consistent airflow through it. So we've spent some time with the design to get everything right so that we get a uniform airflow through to get consistent drying. These here are just prototypes yet. The real ones, the tubes look pretty much the same, but the control panels and stuff like that are we're still updating these to the new versions. So the way a walking floor works, it's like 3 sets of sections. It will go. The oil is cold, so it's a little bit slow right now. I'm not sure if it's quite working right. The way it's supposed to work is all of them go together one way to walk it in, and then when they come back out, they go in 3 stages so that it doesn't move the hay. Same concept as walking floors in trailers. They're coming down slowly there. And the side flaps won't come in until there's pressure on the top ones. So you won't see them move until it's all the way down. It'll come all the way down to under 3 feet for the 3-foot bale. Actually, they're not 3 feet, they're 32 by 34 inches, so it comes down quite a ways.
The load cells, is that to monitor progress in your drying or just the total input?
Just a total. Yeah, these have load cells on too, and that's an option. We were hoping that it would help us with knowing when it's dry, but because of you can still have wet spots and not know it, so it's a good indication of where you're at, but it won't tell you when it's dry. So at this point, we still have to go inside to check manually, and you get a good idea though by the weight. We are working on dryer probes as we speak to help monitor it, and we have a broadcasting unit, it's called, which will be hooked up with the internet and your cell phone, that you can actually check the status of the drying, and it will tell you when it reaches a certain point. But we're still working on that programming at this point. So we're hoping that with probes that we can perhaps tell when it's dry and actually remotely shut it off. So. Any questions?
Why propane on the engine?
Why propane on the engine? It's as a fuel, it's probably not much cheaper than diesel fuel, a little bit. The main reason is because I didn't want a Tier 4 engine in this thing. That just only runs once in a great while. If you have a Tier 4 engine, you gotta be running it frequently. And the cost. It's a lot cheaper than a Tier 4 diesel engine. And it's just as efficient. It is a Ford industrial engine. Will it last as long? Probably not, but it is supposed to last a long time. And if you go to rebuild it, it's probably only going to be a quarter or third the price too. So.
What's the return on investment on this unit? Like, how many bales would you have to be rolling through to make it profitable?
Yeah, return on investment, that's a bit of a wild card. I made a bit of a manual spreadsheet on that, and you have to do a lot to pay it back. So I like saying you get it paid back by selling a premium quality hay. That makes a huge difference. If you're just going to use it to dry normal hay, you can save the hay. Like the last 2 years, everybody, I don't have to talk about the challenge of making hay the last 2 years. We didn't have the stress that you guys did the last 2 years.